Okay, so let's talk then about the binary API world here. MacSwap.api is a real simple binary API to control the feature. It has an enable disable thing which says client index. Yeah, I mean, God, I was actually pretty good about this. A comment or two. I shock myself some days that I actually comment anything, but I knew this day was coming, so I tried to be careful about it. Anyway, the API, the API test tool, or any client, in fact, can put an arbitrary 32-bit context so that it can match requests and results depending on how asynchronous the thing is. This is a real simple API. It's a U8 enable disable. Also takes the interface handle. And the reply to it is going to pretty much be 0 all the time, because unless you fed it a ridiculous software IF index, you'll get 0 all the time. Let's just for giggles fire up the API test tool and show you what happens when when you do pass it some utter nonsense. Let me just get a terminal going here. Oh, this is already terminal, isn't it? All right, shell, new window, basic. Okay, jump into the VM here. Oops, how about jump into the right directory? VPP, VPP, build, root, bag, rat. Oh. Okay, all right, that took a week. Test. Okay, notice here the API test tool will tell you a little more loudly. He just loaded the MacSwap test plugin, and now if we type help here, you'll see that this guy knows how to do. If I get the window big enough, this guy just, let's look under MacSwap. See, he now knows the MacSwap enable disable API. But again, here's a plugin. Here's a plugin for the API test tool. Most likely, if you're building a feature as a plugin and you have a full board control plane, you really ought to build the API test tool plugin. You don't necessarily have to. I would always do it because, again, it's the gold standard and easy ways to replay this stuff later. Yeah, exactly. Dave pointed out exactly the reason you don't want to be lazy about it, which is that one of the things we hope folks will do will be to contribute tests for their features. And if you build a test as a plugin, at least initially, the other little political rap about plugins are, I have no agenda at all about what people do in plugins. If you want to replace the IP4 and IP6 stacks, particularly with something better, start off in a plugin so you're not wasting your time rebuilding the engine, and eventually you can throw it in. In almost every case I can imagine, there's an API-ish way to adjust the way packets flow in the graph. This one is, the control plane side of this particular plugin, which we're going to look at in a second, actually uses device driver RX redirect, which is a fancy way of saying, hey, Mr. Device Driver, I want first call on every packet from a particular interface. It's a great way of just divert everything over here, and anything you don't like, you can throw back at either Ethernet input or IP4 input, IP6 input, one of the input routines. That's actually a common way for maximizing performance in special use cases of saying, look, I know this is a trunk pipe. I know I'm doing a very particular feature and only a feature on a particular interface. Give me all the packets off of it. And oh, by the way, if I need to handle an ARP request or something odd, I'll just throw the thing at Ethernet input and let it do its normal thing. This is that API, which I'll show you in a second, is right of first refusal on every packet on the interface. But let's quickly just do the I'll show you what happens at the API level if you send a garbagey software IF index. So, Mac, oh gosh, sorry. All right, okay, well, yeah. I should have done help MacSwap enable, but I got enough out of that. Yeah, and that's what the API will tell you, that I had a lot of fun over the course of about a year bulletproofing the API so that not only do they return fairly obvious errors, but also so that silly things like just sending the wrong software IF index down the pipe isn't going to kill anything. So now let's actually do something more sensible with it. IF index 5. And that'll actually just go ahead and work. And now, someplace in a window far, far away, I was actually earlier trying to ping the thing and getting very little love from it. Let's, oh gosh, I'm just doing really badly now. That gets to be, oh, okay, Emacs. Let's just do that ping again, and now it should. Now it'll work because we're not swapping. We're not doing the max swap anymore. So you know, feature turn on, feature turn off. At this level, the plugin is totally out of the way. So meanwhile, back at the back at node.c over here. So we've kind of beat this one to death. It takes a certain amount of time to understand all of the boilerplate here. I've tried to go through it a little bit. Now let's go look at Mac. This is the kind of the main routine, which actually, yeah, all right. Let me look for, let's look for the thing, Mac swap init. All right, how about, okay. All right, Mac swap init. This is the init routine that, you know, like all of the init routines, absolutely, you know, actually compiled into the engine, will be run as the thing fires up. The game here is to say, look, I want to register with the engine. You know, this is the data plane piece. I want to register with the engine a particular API that the control plane portion can find by name. The API version there, you know, so I've said plugin name convolved with the API CRC signature. It's an important kind of idiot proofing, because if you end up with an old plugin and a new control plane API, you don't want the control plane to connect. You want a fairly obvious error message saying, dude, you really want to clean up here. And the way we canonically arrange that is to say, okay, make up a name, then get a block of message IDs. In order for multiple plugins to play nicely with the other children, each one of them knows how many APIs it's going to donate to the cause, and we want a unified numbering space. So what I do is to you know, have an API called VL message API get message IDs, which says, okay, message first available turns out to be, here's how many I'm going to need, and here's the name I want to blame them on. You remember earlier, and I might as well do it again. We can say show API mess. Notice 216 is Mac swap enable disable, and you notice how the space is nice and dense. No handler typically means this is a reply handler for something where the data plane gets a request and the client gets the reply. So no handler means message, you know, it'll squawk a little bit and you'll actually get a syslog entry if that's ever happening in the data plane. But it doesn't break anything. It just says, there's no handler for this, toss the message and be done with it. You know, not wholly unreasonable, but at any rate, at the plugin level, you say, give me a message ID base, give me a block of message IDs to use, and you know, assuming that all kind of works, then the hooking up of the hooking up stuff is done, you know, in a pretty obvious way. VL message API set handlers says, you know, here's the you know, the message handler, that's a data reclamation if for some reason you choose to allocate extra space in shared memory and the client quits and it wants to clean up mumble. This guy's not going to do that because the message API is very simple, so on and so forth. Here's an endian swapper. Potentially useful when interoperating between big and little endian. don't hold your breath. You're going to want to do that anytime soon. And a pretty print function for the guy. These for each macros, this is a piece of Barrack and Dresselhaus nonsense. Have you guys noticed these yet? At any rate, what they are. All right, let's go find that one. Okay. This is almost a Lisp Lambda function where what I'm torturing the preprocessor into doing here is I say, okay, for each one of these guys, run the underscore macro. And the underscore macro is defined locally so that you can do clever things like have a guy like this that has effectively a 2-column list or an n-column list, and you can populate multiple data structures without the worry that somebody's going to accidentally sort them for you. It's just a piece of Dave coding, but I do use it all over the friggin' place. For each mac swap. And what I've done here is I define the underscore macro briefly. I instantiate it so that you get VPA message API set handlers across the entire set in that list, and then I use a little preprocessor pasting magic to make it all nice. That for those of you that may not play these games a lot, pound lowercase n means make me a string with whatever whatever n had in it. Other places I'm using the paste operator, and I use the capital N guy there to say VL API mumble plus the base. This actually is how how all the plugins play nicely with each other if you insist on the use of adverbs. Anyway, so there's that one. There's one other method. Have we gone through here in excruciating? Oh, yeah. So here's a debug CLI command. They're actually real easy to do. The path is what the user has to type to get there. In this case, mac swap enable disable. The short help is what it is. If you go in the data plane now, the data plane plugin's there. If we say help max, right? Max. It'll give you that short help when you've descended the parse tree just enough to do it, and it's really kind of nice manners to actually do that for people so they're not wondering, in particular. Now, what this guy does is to say, you remember I had this little rap about these guys are based on format. Well, after lunch, assuming everybody hasn't run for the hills, we'll talk a little about VPP infra, the place where unformat and its friend format actually live. This %U game is unique to format and unformat, and it says, okay, here's the function that will actually unformat a VNet software interface for you. That's off in the base package. It knows how to take the string of characters you've typed and go give you back the software IF index. And what I'm doing here is a function that's broken up just the way I said I wanted to, where we do some read stuff from the user, assuming that they bother to give us an interface. CLib error return coming out of here is just going to print that. Like if we were to say here, max swap, okay, if you really type nothing, it'll do that. It'll say, please specify an interface. There's a little bit of sanity checking. Then what I do is I call an action function here called max swap enable disable. Not the command guy, but this is the guy that actually is the action function that's shared between the message handler and the debug CLI. And the right way of saying it is if the software IF index is completely wrong, it'll give you a nice error message. The current epic catalog of all such things, NX, find global definition. Okay, yeah. Again, this is a little bit a victim of, VNet API errno.h. As you'll see, I don't bother so much with getting paid by the pound to type stuff. here's another one of my magic for each macros, and here's the set of, of API errors that exist today. And it turns out it's fairly complete, extending that an obvious thing to do so that you can return status that will make sense to someone at the API test tool level, where you can say, invalid decap next, whatever. You can say something that'll mean something when people see it. If you tell, if this at the max swap enable disable level, VNet get software interface is a fairly common thing to say. It takes one of those magic small numbers and gives you back the underlying data structure. I probably don't want to do a recursive descent into that one because we're going to blow into lunch and we'll never get there. The API that I'm using to steal all the packets from from a particular interface is this VNet hardware interface RX redirect to node. Node index is the node index of this guy, as you'll see. Twiddle 0, interestingly enough, to this API means turn off the redirection. So you can turn it on, you can turn it off dynamically, no problem, and that's how you do it. So now, this is a piece, this is just sort of a handy way of doing stuff. Right. Here's the actual the control plane API message handler, which says, I'm sitting in the data plane now, and you'll notice the end AHL. For the longest time, you're going to be sick of me for making all the messages in network byte order. The reason to do that is purely for interoperability between big and little endian architectures. We're all network guys, so we're all trained to use network byte order. NDHL will obviously do the right thing in a big endian or a little endian architecture. There is a CLib variant of this which has a name that's about as long as your right arm that nobody wants to type. So I canonically, will use the Linux typical macros. So, at any rate, what else is there? There's the one other thing I really want to show you in here. Max swap, grep. There we are. Yeah, I wanted to find VLib plugin register. This guy exists to convince, as the comment says, it exists to convince the plugin framework that we haven't accidentally copied a dirty GIF or a random DLL into the directory. And if the DL open works, but this name is not present in the data plane or it's analog in the API test tool, it'll give the plugin the bum's rush. Now in this case, pretty obviously, if we get here, we're going to return 0. The idea being you want to capture these three things out of the plugin handoff structure. Yes, we could add accessor methods, but to be honest about it, every plugin, every piece of network code is going to want to know where's VLib main, where's VNet main, and most likely where's Ethernet main, especially for something like swapping MAC addresses. You want to know those things. So again, this method exists to to convince the framework to load the thing. Sample. Whoops. Oh, come on, max swap. Sorry, my macros are smarter than I am today. This is a plugin for the API test tool, which makes it so that again he knows how to do the thing. As you get into the API test tool, if you do, you'll realize that this boilerplate is really pretty straightforward. There's nothing too complicated about it. Again, I just phrase all of these things exactly the same way. What you want to do to make a plugin API handler is, again, even on the API client side, it's remarkably follow the same pattern. Unformat the user input, construct the API message, send it, and wait for a reply. You can look in excruciating detail at this stuff, but that's basically what it takes to teach the API test tool how to send binary API messages. It's really nothing. And it's all boilerplated, and there are Avogadro's numbers of annoying examples. The difference between code here and code directly compiled into the API test tool is not a whole hell of a lot. That when you're working on the main stack, which I expect people are going to want to do, this stuff goes into the API test tool itself as opposed to into a plugin to the API test tool. It's just a very symmetric setup.